Okay, so we're starting with chapter 31 of my new book, Overcoming ACT Math. This is the absolute value chapter. So really quick before we get started, if you have an earlier copy of this book, there's just a slight misprint on the answer key for number 11. Just know that that should be E actually. And then I just want to go over a quick summary of what you need to remember when you're doing absolute value. So just remember with absolute value, essentially what it means is that if you have a negative number, like let's say you have -1 inside absolute value bars, you just turn it positive. Same thing with just positive one, it just stays positive. So absolute value just means whatever's inside is positive. And then if you have an equation with absolute value bars, like let's say you have x minus 2 is equal to 4, then what you need to do is you set it equal to the positive version and the negative version. So for instance, the number inside, it could be equal to -4. Because we could say that the absolute value of -4 equals 4 as well as the positive absolute value of 4 equals positive 4 as well. So this could be -4 or it could be positive 4 and it still equals 4 when you take the absolute value of it. So we would just do those two equations. X minus 2 is equal to positive 4 and x minus 2 could be equal to -4. So then we would add 2 to each side and we would get x is equal to 6 and we would get x is equal to -2. Now make sure that you plug these in to check them because it's not going to be in every single case where it works out perfectly. In this case it does, where if you plug in -2, you'll see that it works and you get 4 when you take the absolute value, and 6 works as well, but that doesn't always happen, so always make sure to plug in to check. And then we have the case where we have an inequality. So let's say that we had, instead of equals, we had that it was less than 4. What you do in this case, it's the same exact thing almost, except you have to remember that when you take the negative, you have to flip the inequality symbol. So this is going to be x minus 2 is less than 4. And then when you turn this into a -4, you have to remember to flip the inequality symbol. So x minus 2 and then flip this to be greater than, and then -4. And then you solve it the same way you do here, except it's just an inequality symbol. So I'm going to add 2 to each side. So I'm going to say that it has to be equal to 6 when I add 2 to each side, or less than 6, sorry, when I add 2 to each side. And when I add 2 to each side here, I'm going to get that x is going to be greater than -2. So that's what you have to remember for that. And then, yep, that is pretty much it. So let's go to the next one, number 1 right here. Remember, if you have my book for the best results, make sure to attempt the problems first before watching the video for explanations on stuff you're stuck on. So number 1 says, given that n is any real number, which of the following is true? So real numbers are basically just like, when you're learning about rational numbers, irrational numbers, all of that, it's like real numbers is the category that encompasses all of that. So like real numbers could be -2, +2, 0, like all of that. Those are real numbers. It could also include fractions and decimals, all of that. So let's just say that n is equal to, I like to test out a positive and a negative number. So let's say n is equal to -2 and n is equal to, we'll say +3. So let's test this out in each of these scenarios. So if we plug in -2 for n, it would be -3 times -2, which would be +6. And then if we plug in -2 for n here, -3 times -2 is going to be +6, so absolute value of 6, that works out. Now let's try it with a positive number, so let's try 3 in place of n. So if I put 3 there, it's -3 times 3, which is -9, is less than or equal to, if I put in 3 here, it's -3 times 3, which is -9. Absolute value of -9 is going to just be 9. So that would work right there, and so we would say that that is true. But if you wanted to be safe, you could do the same thing and plug these into each of these equations and inequalities right here, just to make sure that none of those worked. But let's go to number 2. What is the value of all of this? So we're going to simplify everything within the absolute value bars first and copy everything else over. So I'm going to copy over the, it's supposed to say plus, -2 plus, and then I'm going to do -5 times 2 is -10, minus 9, close the absolute value bars, and then I'm going to copy over the rest. So -10 minus 9, that's going to be -19, so the absolute value of -19. And I'm going to copy over everything else. Now I'm going to take the absolute value of each of these. So I'm going to say -2 plus absolute value of -19, I just turn it positive, 19, minus absolute value of negative 3 is just 3. So now I just need to solve this. So negative 2 plus 19 is going to be 17. 17 minus 3 is 14, so it's H. So let's go to number 3 now. What is the solution to the following inequality? So right away, this is saying that we take the absolute value of 3x and it has to be less than negative 3. That's impossible because remember, absolute value means you make whatever it is positive, whatever's on the inside positive. So it can never be less than negative 3 because it can never be a negative number. So there would be no real solution to this one. So let's go to number 4. Which of the following is the solution to this? So I'm going to divide each side by 2. I want to get the absolute value bars by itself, so that's why I'm doing that. So when I divide each side by 2, it cancels out on the left-hand side, and I'm left with 4 on the right. So now what I'm going to do is I'm going to set it. I'm going to set the absolute value to the positive and the negative version of 4. So the positive version would be that this is greater than or equal to positive 4. Now the negative version, remember, with inequalities, if you divide or multiply by a negative, you have to flip the symbol. So when I do the negative version, I have to flip the inequality symbol the other way to make it less than or equal to negative 4. Then I'm going to solve it by subtracting 4 from each side. When I subtract 4 from each side for the first equation that I have, or first inequality, sorry, that I have, I'm going to get that x is greater than or equal to 0. And then when I subtract 4 from each side over here, I'm going to get that x is less than or equal to negative 8. So x can be greater than or equal to 0, or it can be less than or equal to negative 8. So we're going to look for what says that. So x is greater than or equal to 0, x is less than or equal to negative 8 would be F. So, and just so you guys know, because I know people are going to start asking, I just did the trig video for the person that asked, like literally before this. I did one of the trig videos, so that'll be up on YouTube soon. And then after the absolute value chapter, we're going to be doing an overall review quiz. So let's go to number 5. The safe level of arsenic in soil is 10 parts per million ppm. If the device used to measure arsenic is only accurate within 1 ppm, then which of the following could show the range of measurements on the device that could be deemed safe? So we're going to say that it has to be, the device can measure only accurately within 1 ppm. So it could be off by 1. So we could have that it's going to be less than 10, or it's going to by 1, or it's going to be greater than 10 by 1. So technically it could be like between 9, x could be between 9 and 11 that they're reading, because minus 1 and plus 1 for the actual safe level, 10. But now you have to think about context. So it says deemed safe. So arsenic, it's like if you have too much, it's bad. So like if it's a safe level, then that means that you can't have basically this more than this. You can't have more than the 10. But the device is off by 1, so it would have to be E, that it has to be less than or equal to 11, because it doesn't really matter if it's also greater than or equal to 9. Like there's no like rule that says that it has to be exactly 10 or something like that. Like if it's less, that's fine. It's just it can't be over that level where it becomes unsafe. So you also have to apply context here to know that it would have to be E. So then for number 6, it says a student is given a worksheet with a number line on it. C and D are 2 different points on this number line. These points are both 5 units away from the point with coordinate 3. The solutions to which of the following absolute value equations give the coordinates of both points. So if we're on a number line and we're at the point 3 on our number line, right? And we want to go 5 units to the left and to the right of our number line. We're going 5 to the left. That means that we would end up at negative 2. And if we're going 5 to the right, we end up at 8. So if these are representing, if x is representing our solution, we want to make sure that negative 2 and 8, our solutions, work in these. So we would plug those in to see if they work. So if I plug in negative 2 here, I get negative 2 plus 3, which is going to be 1. Absolute value of 1 does not equal 5. That doesn't work. Now I'm going to plug in negative 2 here for g. Negative 2 minus 3 is going to be negative 5. Absolute value of negative 5 does equal 5. Let me check the other one now. 8. If I plug in 8, 8 minus 3 is going to be 5. Absolute value of 5 is 5. That works as well, so it worked for both of those solution values, so it's going to be G. And x minus 1, absolute value of x minus 1 is equal to, if I divide each side, I get 8. So then I get x minus 1 is equal to 8, or x minus 1 is equal to negative 8. So then we're going to add 1 to each side. So x is equal to 9. Add 1 to each side. I get x is equal to -7. So then you could plug them in just to make sure for each of these, but I don't need to do that because I see it's multiple choice and the answer choices, like it could only be one that includes 2 different answer choices, and these are the only 2 possibilities. So it would have to be H. Which of the following is the solution to this right here? So we're going to add 6 to each side. So we're going to get 6 is greater than or equal to 6x minus 2 over here. Absolute value of x minus 2. So we're going to divide each side by 6. So we get 1 is greater than or equal to x minus 2. So then when we do that, we're going to say, okay, x minus 2, we could have it. Oh, I wish I had more room here. I'm going to try to write as neatly as possible, guys. So 1 is greater than or equal to x minus 2. And then we would say, if we flip it, -1 has to be less than or equal to, or it has to be x minus 2 has to be greater than or equal to -1. So then we would say that this is going to be 3, and that this is going to be, plus 2, and then plus 2 is going to be 1 less than or equal to x. Okay, so it could be anything that is between, or x is greater than or equal to 1, and x has to be less than or equal to 3, so it would have to be E. Okay, so let's go over here. Suppose a manufacturing company has a requirement for, why is it so blurry? For a steel rod to be 10 inches long, but it allows a margin of error of ½ an inch. Which of the following inequalities below represents acceptable lengths for the steel rod? Okay, so it has to be, it could be 10 inches, it has to be 10 inches long, and margin of error means like how much it could be off by, so it could be off by ½ an inch. So like, let's say that it could be like 10 minus ½ of an inch, or it could be that it's 10 plus ½ of an inch is what that margin of error means. So it could be 10.5, and then it could be 9.5 is the other option over there. That's like what the margin of error part is. So what you could do is you could start plugging in possibilities if you want to over here, or you can just kind of like understand the context of the problem. So like this first one, F, is saying that if we take away 10, like from whatever the length of it is, that it has to be less, the absolute value of that has to be less than or equal to 1/2. Now, if you plug it in here, like you would do 9, if you do the plug-in method, you could say 9 and 1/2 minus 10. That's going to leave you with -1/2. So the absolute value of -1/2 is just +1/2. That is less than or equal to 1/2. And then for the 10.5, you would do 10.5 there, and you would say, okay, 10.5 minus 10, that would be 1/2, so that is less than or equal to 1/2. So like you could plug in to kind of see as well, or you could just have read it with the context of the problem that it has to be like the margin of error is 1/2, and then it has to be, the requirement is that it's 10 inches, and that's what this one says, F. So then let's go to number 11. So then if n is a real number, then which of the following must be true? Again, real number, that just means like it's basically the anything. Like it could be negatives, it could be positives, it could be zeros, it could be fractions, all that. Rational, irrational. So then what we're going to do is if n is a real number, then which of the following must be true? So I'm going to just say like I'm going to use a -2. I'm going to use the same values I did last time. A -2 and +3 because I'm trying like a negative and a positive. So -2, could that be greater than or equal to 0? No. So we're going to cross out A. So then what I'm going to do next is I'm going to try for B. So then negative of -2, because I'm plugging -2 for n, has to be equal to the absolute value of -2. So -2 is +2. So you're going to have +2 is equal to absolute value of -2 is +2. So now let's try it with the positive number. So now I'm going to say negative of +3 is equal to the absolute value of 3. That's not right, so it's not that one. So then let's go to letter choice C. So then we're going to have that -2 is equal to the absolute value of -2. So it can't be negative. You can't like take an absolute value and get a negative number, so it's not that one. So then let's try this one. We're going to get -2 is equal to the absolute value of the negative of -2. So then that's going to be -2 is equal to, and then negative of a negative is positive. So -2 is equal to +2. That's not right. So it should be E, none of the above. what is the solution set for the equation right here? So I'm going to get absolute, whoops, let me rewrite that. Absolute value of negative 3x plus 2 has to equal the absolute value of negative 10 is just going to be positive 10. So that means that negative 3x plus 2 has to equal, it could be equal to positive 10, or it could be equal to negative 10. So I'm going to get x by itself in each of these equations. I'll start with this one. I'm going to subtract 2 from each side. When I do that, I get negative 3x is equal to 8. So then I'm going to divide by negative 3 on each side, so I get negative 8/3 when I do that. And now I'm going to solve for x over here. So I'm going to subtract 2 on each side. When I do that, I get negative 3x is equal to negative 12. So then we're going to get that x is equal to positive 4. So those are the two options, but remember you always want to check that they actually work. So I'm just going to plug that in to make sure that they actually work. So because there's options that say like that it could be other things. So I just want to make sure it's not one of those. So then when I plug in negative 8/3 over here, I'm going to get that the 3's cancel out, and I'll show you that. I should just write it out instead of saying it. So that's what I'm going to do. I'm checking that this is basically true. So these 3's cancel out, so negative of negative 8 is going to be positive 8, so positive 8 plus 2 is going to be positive 10. Absolute value of 10 does equal 10. That works. Now I'm going to do the same thing, but I'm checking with the 4 as the x. So I'm going to say negative 3 times 4 plus 2, does that equal 10? So negative 3 times 4 is negative 12. Negative 12 plus 2 is going to be negative 10. So the absolute value of negative 10 is positive 10, so that works out. So it should be both of them, 4 and negative 8/3. So that would be H. So let's go to number 13. In order to be allowed to go on a playground, children must be older than 2 and younger than 8, which of the inequalities represent this situation. So number 1 is easy. This says like X is the solution, that their age is the solution. It has to be older than 2, younger than 8. That works out. Now, if you're in a rush, if you had to guess, you could automatically just say, oh, it can't be those, and I have a better shot at getting it right, just so you know, but we're going to keep going with the problem. So we're going to go to number 2, and we're going to say, okay, if I solve this out, do I get that same inequality? Let's see. So x minus 5 has to be less than 3, and then I set it to the negative, so x minus 5 has to be, and then we could say greater than negative 3. So then we can add 5 to each side, so we say x is less than 8 and x is greater than 2. So then that works out, that fits with the inequality over here. And then we could say that we have x minus 2, we're doing the same thing but with this version right here. X minus 2 is less than 8, x minus 2 is greater than negative 8. I flip the inequality, so I'm going to add 2 to each side, so I'm going to get that x is less than 10, and x is greater than negative 6. So that's definitely not what that is. So it could be, we said it could be number 1, it could be number 2, it cannot be number 3, so it's C, 1 and 2. So now let's go to number 14. In order to minimize risk for customers, a fireworks company's policy requires that each bin of fireworks be kept at least 40 units away from the nearest customer. If a bin of fireworks is located at coordinate 20 on a number line, at what coordinates could the closest customers be located? So let's say it's at 20. This is our number line, 20. So they have to be at least 40 units away. So they could be 40 units this way or 40 units this way. So if we go 40 units to the left, that's 20 minus 40, which is going to be negative 20. If we go 40 units to the right, it's going to be up 40 units, so that's going to be 60. And remember, it can be that that's just at least how far they have to be away. So it could be negative 20 or anything over here. And then it could be 60 or anything over here, because this is where they're trying to get far away from. So if it's these values, that's talking about x is less than or equal to negative 20. So x is less than or equal to negative 20 would be this one. And then over here, it's x is greater than or equal to 60. So it would have to be F. Let me just fix that really quick. Okay, so let's go to number 15. So it says for number 15, we have this. For the equations shown above, what are all possible solutions? So what you can do is you can literally just start plugging in if you don't know how to solve this. That's another strategy, but that takes you a long time. So I'm not going to do that. So I'm going to divide by 2 to get the absolute value bars by themselves instead. And I'm going to say that this is equal to, I'm just dividing by 2, 5x minus 4. So now what I'm going to do is I'm going to say, okay, I could say that 3x minus 7 is equal to 5x minus 4. Or that could be the negative version of that. So I could say that 3x minus 7 is equal to negative 5x plus 4, because I'm just multiplying that by a negative 1. So I need to solve both of these. So if I subtract 3x from each side, I get negative 7 is equal to 2x minus 4. And then I'm going to add 4 to each side. So then when I add 4 to each side, it cancels out on the right, and I'm going to get negative 3 on the left is equal to 2x. And then I divide by 2 to get x by itself. So I get x is equal to negative 3 halves. And then over here, I'm going to add 5x to each side. That's going to give me 8x minus 7 is equal to 4. Then I'm going to add 7 to each side. I get 8x is equal to 11. Then I'm going to divide by 8, and I get that x is equal to 11/8. Now, this is just the improper fraction format. Like, I could turn them into these after if I want to. But first, I'm going to check if these work. So I'm going to check them by saying, okay, I'm going to plug in for x. I'm going to start with negative 3 halves. So 3 times negative 3 halves for x minus 7, the absolute value of that, does that equal 5 times negative 3 halves minus 4? So right away, I can say, no, this is absolutely not going to work because this is going to be a negative number minus something, so it's definitely going to equal a negative number, and this is absolute value, so it can never equal a negative number, so this does not work. Now, by default, I know that this has to be the one that works. So, but if you want to check it, I'm going to just show you how. All you do is you plug in x in the equation right here, and you would say 3 times 11/8 minus 7, absolute value of that, is equal to 5 times 11/8 minus 4. So then what we're going to do is we're going to say, okay, does this work? Well, let's check. So absolute value of 33/8 minus, and this is going to be 7/1. I have to make a common denominator of 8, so I have to multiply on top and bottom by 8. So that's going to be minus 56/8. And that's going to be all equal to 55 over, not over 40, over 8. 55 over 8 minus 4/1. So I have to do the same thing with the 4/1 over here. I have to make a common denominator. So then it's going to be absolute value of 33/8 minus 56/8 is equal to 55/8 minus, it's 55 because 5 times 11 is 55, minus 32/8. So now I'm going to subtract. So then I'm going to get that that is equal to, that's negative, is that negative 23? Let me think for a second. Negative 23, yeah. That is negative 23. Negative 23/8 is equal to, and then over here, we're going to get that that's 23/8. And the absolute value of that would just make it positive, so that does work. So it would have to be the 11/8 one. Now the way you turn that into a mixed number is just, that says 11 divided by 8. So 8 goes into 11 one time. 1 times 8 is 8. Subtract, that's 3. Whatever your remainder is goes as your numerator in the mixed number, and the denominator is the number on the outside of the long division house. So then it's 1 3/8 D. So now we have number 16. Which of the following could be the graph of this? So remember, one of your parent functions is the absolute value of x graph. Like, this is equal to the absolute value of x. It's one of the ones you memorize. Now on the ACT you get a calculator, so you could always like check this all on a calculator if you want to, but I mean, this is faster. So this is the parent function. That's what it always looks like. It's a V where the vertex is at the origin. So if we're doing this right here, this just says that next to the x is a minus 3. What that means is that you're actually going to the right by 3. So you have to do right by 3 for this entire graph. So the vertex, you could just say, okay, it's going to go to the right by 3. So which of these shows this going to the right by 3? Well, if you look at all the options, the one that goes to the right by 3 is C. So that would be the correct one. Okay, and then let's try number 17. And I put these every so often in the book just because I've had a couple students, even though I tell them before test day to change out the calculator batteries, that just over the years they haven't, and like on test day their calculator dies or something. So that kind of stinks. So just in case, so you practice your algebra periodically, that's why this is not multiple choice. So what we're going to do right here is it says 4k plus 7 equals 0. K is the solution of the equation and k is less than 0. What is the value of absolute value of k? So 4k plus 7 is equal to 0. So we're going to subtract 7 on each side. We get 4k is equal to negative 7. If I divide by 4, I'm going to get that k is equal to negative 7/4. But I want the absolute value of k. So that's going to equal to the absolute value of negative 7/4. So then that's equal to 7/4.